Hello and welcome back to the second video of the video series on KNX IP. Now that we know the basics of the IP technology, we want to take a look at the basics of the KNX IP technology. So for example, what is a multicast address and how does the communication with KNX IP even look like? Due to the physical structure of KNX, the telegrams are sent to all network devices at the same time in KNX twisted pair. This means that every device receives the same telegram at the same time, no matter which physical address they have. And in order to be able to maintain this functionality in KNX IP, the so-called multicast address is used. As already discussed, the IP address is sort of the house number or the address of a network device. So therefore, an address is required to which all KNX IP devices can react. And by default, this is the 224.0.23.12, and it is reserved by the IANA for KNX IP. In this Wireshark example, you can see that two devices are communicating with each other via KNX IP. First of all, we have the device with the IP address 0.51 at the end, and the second device has the IP address 0.59 at the end. But you can also see that the destination address of a telegram isn't the address of the other device, but instead it is our multicast address. So the telegrams are sent to every KNX IP device on the network via this multicast address. And then in the information field, you can see the value and the group address that is going to be sent. So in the first telegram, for example, we can see that there is a message sent to the group address 4/0/4 by the physical address 1.1.30, and behind that we can see a value which probably is an analog value. Then the second telegram, there we have the address 001, so the physical address, and a telegram to the group address 5/4/1. And now in this case we can see a write telegram with the value 0. So in this telegram something is going to turn off, for example the light or a channel of an actuator. So you can see that in KNX IP we have the same functionality as in KNX twisted pair. We also send on the IP side the telegrams to all KNX IP devices, and then they will take a look at the group address and will decide whether they have to react to this telegram or not. But let us take a look at a sample network. Here you can see a completely normal home network with a router, a Wi-Fi network, smartphones and computers. In addition to that, we have now connected KNX IP devices. On the one hand, a KNX IP multi-IO and a KNX IP router. The KNX IP router connects the KNX twisted pair network with our IP network, and from our KNX twisted pair network we are initially only looking at one push button sensor. This push button sensor is parameterized in such a way that it should switch a digital output from the multi-IO on and off. But how exactly does the telegram now go its way? Well, first of all, we have to operate the push button sensor. Then the push button sensor sends a telegram to the KNX bus as usual. This contains the group address as well as the value to be sent. The push button sensor itself doesn't even know that the telegram will go via KNX IP. So far, we have the same case as in a KNX twisted pair network without an IP connection. So you can see the group address is 1/1/3 and the value we want to send is on. But now it's getting interesting. The KNX IP router knows, because of its parameterization and the so-called filter table, that the telegram is being used by a KNX IP device. Therefore, it sees this telegram and converts it to the signal from a KNX twisted pair protocol into a KNX IP protocol. Therefore, it converts the telegram from a KNX twisted pair protocol into a KNX IP protocol. So it packs the content in the IP protocol. But how does it look now? Well, we see that one information has now been added to our telegram, namely the IP address. This is the previously discussed multicast address. So the telegram is now on the IP level and was addressed to the multicast address. As a result, all network devices ignore this telegram since this IP address has not been assigned to them. Only the multi-IO recognizes the IP address as a KNX multicast address and knows therefore that the telegram is a KNX telegram and checks whether it should process the group address or not. Because of its parameterization, the actuator now knows that it should react to the group address, and as a result, it is going to turn on the light. So we see the functionality of KNX IP is identical to the function of KNX Twisted Pair, only with the difference that the KNX information is once again packed into a KNX IP telegram. But let us compare KNX Twisted Pair and KNX IP. In KNX Twisted Pair we have a data rate of 9600 baud, which corresponds to approximately 50 telegrams per second. On the other hand, the network speed with KNX IP varies depending on the installation. For comparison, we have a data rate of 10,000 megabit per second with the Cat7 installation, which is 1 million times faster than with KNX Twisted Pair. Therefore, KNX IP is often used for the backbone, and there is virtually no limit with a clean network infrastructure. Another advantage is that the existing network structure can be used together with the Wi-Fi. So in KNX IP we use our existing network infrastructure, while on KNX Twisted Pair we have to install the bus wire. But is KNX IP even secure? When using KNX IP Secure, the telegrams can only be read out if the key is available. Otherwise, the same applies as for KNX Twisted Pair. So here you can see our KNX IP telegram, and with some additional informations like the Ethernet IP and TCP/UDP field, but we will take a look only at the KNX IP block. And now we don't use KNX Secure. Now, if we take a closer look in this KNX IP field, we can see its content with the group address, the value, and the sending physical address. The same as with KNX Twisted Pair. Because when we connect our laptop to a KNX Twisted Pair network and there isn't used secure, well, then we have the same thing. We can see each telegram with the informations and its content. So this makes the group address, value, and sender address visible. But what is now when we use KNX Secure? Well, we can now imagine it like a safe in which we pack the actual information. The devices can only read the content with the correct key, so it can only open the safe when it knows the key. So if we now want to take a closer look at the KNX IP field, we have this KNX IP Secure header and the secure wrapper, and so therefore we only see zeros and ones. So without a key, the KNX Secure telegram isn't readable. In order to be able to use this function, the devices that should communicate with each other in encrypted form, they need to support KNX Secure. So here an example, we can see the KNX IP router Secure 752, which supports the secure functionality. So that was a lot of information. Therefore, let's sum it up again. In order to be able to address all devices at once in KNX IP, the so-called multicast address is used in order to obtain the same functionality that we have in KNX Twisted Pair. This multicast address is reserved by the IANA for KNX, to which all KNX IP devices listen. So the functionality resulting out of this multicast address is that when we send a KNX IP telegram, the destination field is our multicast address, which we saw in the Wireshark example, and so therefore all KNX IP devices are addressed with the same telegram. And the real target then is defined by the group address. So we saw in the example that the router sends a telegram to the network with the destination of our multicast address. The KNX IP device, our multi-IO, listens to this IP address, and every other KNX IP device also listens to this address, and then they decide, based off the group address, whether they have to react to this telegram or not. And encryption can be achieved by using KNX Secure, but it is important that the devices need to support KNX Secure. So we can see KNX IP and KNX twisted pair are, from the functionality, nearly the same, only with the difference that we now pack our KNX TP telegram inside an IP telegram. But the functionality that results out of this is the same, with the big advantage of the speed and the option to use our existing network infrastructure. So now that we know the basics of network communication and KNX IP, we want to take a closer look towards the first KNX IP devices within the next videos.